metal has to be something in group 17. All right. How many do I have in group 17 today? One. It has to be Br. All right. While I'm thinking about it, and it's popped in my head. Reactive is also metallic. Those words are often used interchangeably, and I probably did not say that when I was teaching that the other day, but a lot of times those words can be used interchangeably. So keep that in mind. Reactive and metallic mean the same thing. Okay? All right, which has the largest boiling point? Okay, the D block, so Ni is good. Who is the hardest?
Nickel.
Okay, boiling point and hardness have the same trend, so Ni is good again. All right, which metal is the least reactive?
Nickel.
All right, I hear Ni again. I hear potassium.
Oh, my bad.
Okay, I hear Kr.
Wait, no, that's not a metal.
All right, so I hear Ni, I hear K, and I hear Kr. All right, now I hear Kr is not a metal. All right, so do we agree that Kr should go because it's not a metal? I agree. Kr should go because it's not a metal. So now we're down to Ni and we're down to K. All right, the question said least reactive. Where's K at?
In period 1.
In period 1? All right, that's period 4, but it's in group 1. What do we know about group 1? It's the most reactive. And the question asks for what? Least reactive. So could it be the least reactive if it's in group 1 and you just says most reactive? No. So Ni was the right answer when people yelled that out. Okay? Now, see how we had 3 Ni's in a row? What did I tell you yesterday when I make up questions? Do I pay attention to the possibility that I would accidentally put the same answer as the same thing 3 times in a row? No. Some of you on a test would think, she's trying to trick me. Could it be the same answer 3 times in a row?
Yes.
No. I have a mistake. I wouldn't have the same answer 3 times in a row. Tiffany's over there laughing, going, I'd do that. All right? Don't get caught up in that nonsense. Okay? If the trend is nickel 3 times in a row on the test on a question like this, then you pick nickel 3 times in a row. Okay? You don't go, oh my God, it can't be nickel 3 times in a row. Yes, it can. Okay? Particularly if there's only one transition element and you know the trend is the D block. Okay? Which element's the least reactive? Questions? We okay with those?
No.
Fabulous. Any questions on anything I handed back?
No.
All right. In that case, find your notes. We're going to finish some trends. We're going to do some practice. We're going to do Kahoot. And then we're going to talk about bond types today. The puzzle that I told you we were going to do, we're going to do on Monday. Because what did I tell you? You can't use on it. You can't use your notes. You get a periodic table. You and your partner will each get to choose one. All right? I always recommend that you choose a different one. One of you choose one. One of you choose a different one. Okay? Who's not here today? Sean, I need to mark that before I forget.
What's JCO?
JROTC Cadet Leadership Camp.
Push. A lot.
Okay, why you gotta start now?
Why you gotta get her? That's what
Exactly.
And I'm in a great mood to message you.
Alright. So when I start this year,
She said, no, you know we mess with each other. I don't know.
Shut
All right, so yesterday we were on ionization energy.
Are we finishing up notes from yesterday?
We're going to finish the last two trends. Alright?
Okay.
So the only two we have left is to finish ionization energy and then to do electronegativity. And we have finished the trends on the periodic table. We've pretty much finished everything that we're going to do with the periodic table at that point. Crap, I forgot to make the electronegativity charts, which we'll need in a little bit. Where did I put that? Oh, 1 second.
This wall.
Hey, one second, Pop Tarts.
What?
Till we finish smoke.
What?
To use the bathroom.
What? She said she had to go to the bathroom?
Yeah, but I'm like, till we finish smoke.
Oh, that's fabulous. Hang on 1 second. Let me go. I set this on my desk. I'll go start this real quick. I forgot this.
What are we doing Saturday?
I don't know. It's lunch.
Thank goodness to you, yeah.
Do it, girl.
Yeah, I think
Yeah, you was like, what you know what I'm saying?
she said yes. I know it's here at school.
You come to
Yeah. I think so.
I think I made her.
And I'll let you know that.
All right, I told them to start. All right, what did we say ionization energy was yesterday? Now that I made the copy of what I forgot.
Energy needed to remove an electron.
All right. Shh. All right, pay attention now. All right, so energy to remove 1 electron. So at the end of class, when we were running out of time, we started talking about the period trend, and some of you were with me, and some of you I think I completely lost. Okay? So let's go back and review the period trend and see if I can pick up the people I had completely lost. Okay? So if we think about what we know, all right, we know about valence or outer shell electrons, right? We know how many electrons are in group 1, and in group 2, and in group 13, and in group 14, 15, 16, 17, and 18. Now, based on what we know that everybody in the world wants to have how many electrons in their outer shell? 8. Okay? So, if all atoms want 8, we know over here, we know it's easy to do what? It's easy to lose. So, over here, right, but remember, ionization energy is about doing what? Losing. So, is it easy to lose or hard to lose? It's hard to lose, right? So, if it's easy to lose and it's hard to lose, what's going to happen as we go this direction?
More energy.
Okay, so it's going to take more energy because it's harder to lose electrons. And we could also say it's closer to 8 electrons. Does that make a little more sense for those people who weren't quite with me at the end of class? Yes? No? Yes?
Maybe.
A little bit. Okay, so for the period trend, as you go right, Ionization energy does what? Ionization energy increases. Okay? Ionization energy increases. Now, that's what we did yesterday. Does the reasoning make any more sense to some of us? Okay. We need to talk about the group trend today. It's not hard. Well, I don't think it's hard. But I don't think most of it's hard. Are we caught up? Go grab my copies.
So where's the Stephanie? Where do we go to? My nose. I got it.
What time is K leave?
KJ, we go to the.
They open early.
I don't know.
All right.
Gene, we go to the.
How about now? We there?
I just don't know what it's about.
But it's a luncheon, like they're here for lunch, so I'm.
Yes? All right.
I was gonna go to a baseball game tomorrow.
It's not what I needed.
That's what I was going to. I was. My boyfriend. Yeah.
I was gonna say, hey, got you a boo, but never mind.
No.
He ain't even in the middle.
All right. The group trend.
Y'all just hurt for each other.
All right, guys, be quiet. Shh. Jaden. So, what happens in the group? All right, if we look at the same things we looked at when we did atomic radius. All right, hydrogen and I won't go any further down than that because that will illustrate our point. Okay, if we look at those configurations, what can you tell me? What do you think the point is I'm trying to illustrate there?
All have one.
They do have one electron, but that's not the point I'm trying to illustrate.
Energy level.
Okay, they're increasing in energy level. All right, so we have increasing energy level. Okay, so 1 ring, 2 rings, 3 rings. Potassium would have 4 rings. Now, what does that mean for the electrons? Okay, this one has its electron there. Okay, remember, ionization energy is about the ability to lose an electron. All right, where is it easier to lose an electron? Where it's closest to the nucleus or farthest from the nucleus? Farthest. Okay? Think about it. If I took 3 or 4 of you on a field trip, what are the odds I'm going to lose 3 or 4 people? Very little. I can keep track of 3 or 4 people. It's like having kids. Most of us can keep track of our children. But imagine if I took all 3 of my classes somewhere.
You're gonna lose about 1 or 2.
I'm going to lose probably more than 1 or 2 of them. I might lose 5, 6, 7 of them. I'm not taking y'all anywhere. Don't worry about it. Now,
What you calling me out, man?
And I know Jessup.
What you calling me out?
Yeah.
I'm not taking y'all anywhere. Now,
So true.
the bigger the atom, the easier it is to lose an electron. Okay? The bigger it is, the easier it is to lose an electron. Justice, lose those headphones back there. Okay? The bigger the atom, the easier it is to lose the electron. Okay? The further that electron is, the easier it is to lose. So, what happens to ionization energy then as we go down the group? As you go down a group, ionization energy decreases. Okay. As you go down, ionization energy decreases. It's bigger. Hold on. Remember, I'm a visual person. So let people catch up. You got it, Xavier? You take some slow pills today? You're riding slower than usual.
You be in the way sometimes, and then I'll be missing it. You know,
Okay. I hadn't figured out how to make myself thinner without eating, or make myself spray on glass. Yes, Andy.
All right.
Most reactive element.
The most reactive, metal or non-metal?
Either.
Metal would be francium, non-metal would be fluorine.
And which one's more reactive?
Of those two, really couldn't say.
Okay.
All right. So, if we talk about atomic radius for a second. What was the trend?
It got smaller. We got that like
Okay, smaller.
And then it got bigger.
It got bigger. All right, now let's draw a picture for what we just did. All right, for ionization energy. What did we just say happened is we went this way. It got bigger. And it got what? It got smaller. Okay? They're what of each other? They're opposites or inverses of each other. Okay? Now, you can choose to learn these either way you want to. I'll be the first to tell you I don't remember both of them. Nope. I only know one. I know atomic radius. But in my head, I know the other one is the what? It's the opposite. Okay? So I know both of them because I know the other one's the opposite. But I can't keep track of all these stupid arrows in my head and all these increase and decrease. It would drive me nuts. But I know this one. And I know it well. Then I know this one is the what? It's the opposite. And so when I drew, and if you look at my answer keys for my test, no, I will not show them to you. I have these stupid arrows drawn everywhere because I know my learning style. I'm a visual learner. So I draw arrows. I draw pictures. So I have these. So in my head, I see the arrows. I see the periodic table and the elements, and I have arrows everywhere so that I know what I've got. Okay? That's my preferred learning style. I know that about myself. You need to figure out what your learning style is so you know how to do that. It may not be arrows. It may not be pictures. But as you cruise through high school, for those of you going to college, you need to figure that out. Okay? It will help you be more successful down the road as you're progressing through life. so you know how to do what you need to do. Okay? Okay? So, who would have the biggest ionization energy? Helium would have the biggest ionization energy. That is correct. Helium is the largest. And who would have the lowest?
France.
Exactly. Exactly. Okay? It's that simple. If you learn it that way. Now, if that doesn't work for you, find a way that does. That's the way that works for me. Now, the last trend we need to learn is electronegativity. And this is the trend that we will use to move with bonding. Okay? Go back. All right? This is the trend that we will use for bonding. So, it sort of leads us into bonding next week. Now, electronegativity. What is it?
Electricity being negative.
It's not bad.
Negative energy.
It's not.
Negative electrons.
Stop. Y'all are never going to get this. First of all, it's abbreviated EN because we're all going to get tired of writing that long word out, both this unit and the next. So it's abbreviated capital E, capital N. It is a measure of an atom's ability to attract electrons to itself in a bond. Sorry, I stood there too long, Xavier, but I need to make sure I get enough apostrophe.
Really?
All right, we caught up? All right, electronegativity is sort of like tug of war. So if we think back to when y'all went to field day, okay? I know, imagine that. These dots, the dots are electrons, okay? And they're being shared between the hydrogen and the chlorine. The question is, who controls the hydrogen's electrons? Who controls the chlorine's electrons? Are they being shared equally between the H and the Cl? Or is one stronger than the other? Now, think of it as a tug of war. If you didn't participate in tug of war, okay, you certainly watched tug of war when you were in elementary school, right? Now, some people always get picked for tug of war. Some people don't. Okay? It's the nature of the game. Okay? Jade was probably never picked for tug of war. You were?
Yeah, I was just in the middle.
Okay. Now, why did everybody get picked for tug of war?
No, I never got picked.
You never got picked? I don't believe
I
that.
got paid for kickball.
Everybody blamed me.
I had to put it
Okay.
Yes.
I don't know.
Okay.
I know.
You grew up now, when you look at the electrons, thinking about what we know, what do we know about hydrogen? It's got one electron, okay? Well, y'all know hydrogen has one electron in the outer shell. How many electrons does chlorine have in the outer shell?
17.
7. Is everybody okay with where Samaria got 1 and 7?
No.
All right. Hydrogen is in group 1. So 1, 2, 3, 4, 5, 6, 7, 8. So hydrogen's here, so that's why it had 1. Chlorine's here, so that's why it has 7. Okay, that's how she came up with those numbers. So if everybody wants 8, what do we know H wants to do with its 1?
Wants to lose it.
Okay, so we know this one wants to lose. And chlorine wants to do what? All right, so based on that, who do you think would control those electrons?
Chlorine.
Chlorine, okay? Chlorine probably controls those electrons, okay? Chlorine's going to pull the electrons towards itself more than hydrogen. And that is exactly what happens if we looked up the numbers on the electronegativity table. Chlorine is a bigger number. It's stronger. It's pulling them more towards itself than hydrogen is, okay? So we want to look at the trend on the periodic table, okay? Everybody got it? Now, the nice thing about electronegativity is that trend, okay? For the exact same reason. Nothing's different except one tiny little glitch, okay? Electronegativity increases and decreases. Okay? Just like, put EN over the top of that. Just like ionization energy. But there's an exception. Okay? The exception is helium, neon, and argon. Now, in order to measure how strong an element is in a bond, you have to form a bond. You have to actually form a compound with some bond. Well, who has never formed a compound? Those three noble gases have never formed a compound. So can we measure their electronegativity? No. So we don't know how strong they are. It's sort of like saying they've never played tug of war. So do we know how strong they are in tug of war?
No.
No. They're like a sleeper cell. They might be the strongest person out there to play tug of war, but they've never played before, so we don't know if they're any good. So we can't put them as the strongest electronegativity because we don't know.
How did they manage to get noble gases to read?
I assume they altered their temperature or pressure and used a catalyst. Would be my best guess, but I don't know. The only thing they've ever done with it is get it to react for theoretical purposes in a lab. They haven't done anything with the compound once they got it to react. It's all been lab-based. Just to say they did. What's the what?
Best lab in America.
I have no idea. I would guess somewhere in California would be my best guess. Yeah. It's nice, but it ain't that nice. All right. Questions? Think we can try some of this? Yeah. Okay.
Yeah.
Let's give it a shot. Then we're going to try Kahoot.
Can I go to the bathroom?
No. Wait, she's got to go past his letter.
Yeah, I should have one.
All
Just give it to me.
I don't know the owl.
I don't know.
Hey,
It's Walt.
That's not my name.
Yeah,
That's not my name.
Or I mean,
that's what's on your birth certificate, right?
I got you on all
What's
right.
ain't Autumn J?
They call me Autumn at work. And I'm like, who jumped
Good
on?
one.
It's Autumn J, right?
No, they like, all of them. I'm like, ooh, all of them.
My fault, it's fall.
I didn't.
All right.
Don't call me.
Did everybody get one?
Yeah.
I didn't skip anybody this time.
You skipped me.
I did?
Yeah.
Oh,
There you go. All right. Use your periodic table and find the answer.
this for everything?
Yes, it has all the trends that we've done on it.
Oh.
Get ready to do something. Oh, Jay. Yep. Remind Jade she has one when she comes back.
How many do I have? One.
Justice has one left. Tiffany's used all of hers. Xavier has one. Darlene has one. Jaden has 1, Celia has 2, Jay has 1, Jonathan has 2.
How many?
If I didn't call your name, you still have all 3.
What are you talking about?
Huh? What'd I say?
When did they use one? I never used that.
If I've miscounted and to your favor, then you're good. Oh, by the way, I went back and adjusted your test grades, and I will be honest. If the rescore lowered your test grade, I did not lower your test grade. It, for the most part, it only adjusted it by 1 question, but a couple of you would have lowered your grade by 1 question. I did not touch it. I only adjusted it to the good.
Okay, that's what I wanted to know.
You were not.
Oh,
Would not have affected you regardless.
oh, I would say it would have.
But I only adjusted people who it would have affected positively. So, but that has been done. I did that yesterday also. Are y'all supposed to be just sitting there talking
You weren't.
about what? Are you working on the trends?
Yes. We are.
Okay. I am sorry I accused you unfairly.
It's okay. Everybody makes mistakes.
Thank you for being so forgiving, Xavier.
No problem.
Yeah. No, it's terrible when I can't remember my own number. What paper? Oh, crap. I didn't know that's what it meant. I had no idea what that was. Yes. I was wondering what that meant. And I was like, oh, newspaper, it's only 1 sheet of paper, Rector. I love you, sheet of paper to put aside the door.
You would think when you get your paper, you would have been.
How you go up.
Oh, that's what she meant.
I didn't. Larry sent me something yesterday that tasted like what? He sent me 2 more texts. That's what he said. You're slow today. I like, I hope to tell you this one. Look, I worked 11 hours today. Give me a break.
It's like $30. That's $30 out of my phone. How much? Like if I get 8 plus $30. No, it's 33. And then if I get 7 plus, it's gonna be 20. So I'm gonna have to take.
Oh, yeah.
I got stuff to do.
It is what it is. It has to be done. Yes, you have 1 left.
No.
Hold on, show me.
No, man, yesterday.
I'm gonna need you. I can't get my
What? Oh, wait, we have an exception.
Okay, I'm not gonna this whole thing. So It's small. It's like friends. Karen. You childish. No. Wow. Y'all childish. Karen. Karen, you're climbing up the
You go down.
It's hard for these two.
What's your password? It's Brandon. Brandon's an issue.
Oh, is it really?
I don't know his last name. What's his last name?
Don't start with a G.
Gil.
Oh, yeah, and I can use these.
Ew, I'm gonna die.
I mean.
Are you serious?
Ew, you like rich, we got
She's so light. You whiter than I am, and I got, and you ain't even got no white to use. Marty. You see nobody. I ain't got none of
No.
No.
You're
Right around me.
Go up there and drink the lemonade with that ugly baby.
Oh, I didn't see it.
Stop sucking in my drink. That's how Zoe be doing.
I ain't had tea in a while.
Hey, why I got a wheel?
You so childish. Like, it don't make no sense.
Okay, you have a pencil belt? I have a pencil trash can. What's yours? No.
No.
If you broke your hand, I'll be able to use it.
That's all right. That's all right.
And the rest of the it's like a bug on a stick. But in the backpack.
And it says largest because it goes small. I'm pretty sure.
No, I heard you know.
I did the good.
We going to you got a zero.
No.
Yeah, you got it. Yeah, it's good.
That's good energy. Let's increase it.
Not necessarily above, actually, like, ready?
Here, we're all the way up here.
It's smaller than this way.
Ew, if you do that, chill. I wanna know.
I'm gonna increase. All right, bro.
You gotta remember that's going to
I use my grandma.
Well, they're not gonna let us take care. We gotta go to the team. They're not gonna let you go.
No,
Just sit down.
here it goes left and right.
I remember I got to wear
I remember it. I remember.
I mean, if I
You're not sure that's what happens. Wait, and I was my legs feel like jello. And that's the most I've ever worn.
But look,
I understand this.
What's your shake?
you don't, you don't.
No, don't do that.
Because look,
Yeah.
You look shy.
in a group.
I'm not gonna go around.
You like, oh, you got on your face down.
All right, we got it. Let's get some answers. Put your phones up. Let's talk. What?
See, I wasn't on my phone.
You were not, Jay. You have done a marvelous job the last few days.
Yeah, my mama been on my neck.
Well, I'm glad she's on.
And I'm just
Always keep
tired.
that foot on top of it, because you are a model child these days. You have been a model child these days.
Why she come back on Monday with a whole attitude?
No.
You like,
So
Well, you've been in model system.
I've been doing my homework.
I know. I think it's fabulous. You've done a great job.
You should be doing this all the time.
Are you doing as well in your other classes too?
No.
I paid attention to most of it yesterday. Okay.
Singing in the practice class?
Yeah, I sing art class.
That's good.
They don't know what. Good. Yeah. I made a 75 on my book. I didn't write my pieces. I wrote it during class. You too?
Well, I wouldn't want you to be. I wouldn't want you to be over prepared.
Yeah, but she wasn't over prepared.
I wouldn't want that to happen.
She was prepared for all of it. I mean, I was listening.
Jay, you got my plastic?
Me and Alex got a couple.
Alright, is that big enough for whoever always tells me to make it bigger?
A little bit bigger.
Oh, yeah. How many tickets they got?
Yeah, well, Jay bought one extra, so.
Alright, are we good?
She really only got 4 tickets.
Alright, so which metal is the most reactive out of those? What'd you pick? SR is correct. So that's to be group 1. There are no group 1s. So group 2 is the most reactive. There are 2 in group 2. MG and SR are both in group 2. And then you pick based on who's further down. Everybody okay with SR?
For metals, it's like the least amount of the, like if they're in group 1 or group 2.
Yep. So you would have picked group 1 first, and then group 2, and
Okay,
then
so it goes from lowest to highest. Yeah.
what do you mean by lowest to highest?
Like whoever is the lowest, that's the most reactive.
Yes. So then further down.
And then for the non-metals, it's the opposite.
Yes. So like in the next one, okay, it asks for non-metals. So, whoops. See, now I got it so big I can't write. All right. So for the next one for non-metals, we would look at group 17, and then group 16, and group 15, but it would be going up. Okay. So this one said least reactive, right? Who's least reactive?
I.
I hear I. I would be correct. Why are you just strolling through my room?
I'm not, I'm just walking through.
And you use my microwave, no less.
Can I use your microwave? Thank you.
Why do you take
A microwave?
They won't take them there.
I live to serve. Anyways, I is the right answer. All right, chlorine is the most, then bromine, I is the least. All right, number 3, which element has the largest ionization energy? AR. Everybody okay with AR?
Yeah.
All right, number 4.
Wait.
I got confused.
I was the AR.
All right, so when you look at this, again, I'm a visual person. I, D. So when I look at them, NA's here, and then MG is here, CL, and AR. Okay, so when I'm looking at them, they're all in the same row. And so I have, it increases going across. So it increases going across, so who's farther across?
Okay, but what about you said this to subject?
Oh, that's for electronegativity. And this isn't electronegativity.
Oh, my bad.
Okay? So that's why it's AR. Okay? Which atom or ion is the smallest?
P plus 5.
Plus 5. Okay? Because the P plus 5 means we did what? We lost 5. Okay? Smallest atomic radius would be who?
Yeah.
Okay? Again, all about some arrows. Decrease, increase. Where are they at? All right, we've got K and RB, and then CA and SR. So I said smallest, right? So that means these two are going to be out. And as we go across, they get smaller. So CA is going to be the smallest. Okay? Highest melting point. What do we look for melting point? D block. So who's in the D block? FE. Who has 4 outer shell electrons? Pb, so A. Plus 3 ion. Al. Largest radius, again, same thing. D. And increase, so who's gonna that be? Largest radius would be, you got K here, and then Mn, Ge, and Kr. So who's gonna be the biggest? Whoops. As you go across, it decreases. So Kr is gonna be the smallest. So K. All right, and the last one, smallest ionization energy. Okay, so increase, decrease. So CS is here, and A is above it, and then Si, and then Cl. So who'd be the smallest? Whoops. Who'd be the smallest? CS is correct. Questions? And again, you don't have to do it this way. This is just the way I do it because I'm visual. You do it any way you want to. Okay? All right, somebody come get my keys. We're going to unlock carts. And those of you who have issues with your phone, lock it up or something. Get a cart. Computer.
Hey, Daddy. You give me thanks.
Or you don't want your battery to go dead. If your phone's about to die, go grab a computer. That's why we have them. You don't have to worry about your phone going dead later in the day. We'll use your battery power.
How much time we got in this class?
It's 11:40 like always.
No, I was at 40 minutes. Oh
Um,
my God, I don't think I'm gonna be able to hold my. Can I take an attention instead of using a pass?
nope, gotta use up your passes first.
This wall.
Yeah.
What would happen if I pulled that?
Aside from the fact I'm gonna be supremely pissed and write you up, it's a 2-inch water pipe, so water's gonna rush out, and I forget the amount of the rate, but it's gonna spray out in about a 5 feet circle.
Have you
Hey,
had?
at the end of the year, can we?
It's a mess.
You ever have to use
No, we have to test it periodically.
you test it when we in here?
No, it's a mess. You need a mop and a giant bucket.
How often do you test it?
Not once a year.
What if you had someone that needed it?
Then we would use it. Are you planning on setting yourself on fire or dosing yourself, putting chemicals all over your body?
So we set Jane on fire.
I'm really gonna burn it in.
I know you got no meat.
So,
Yeah, we want to set somebody on fire. That sounds like great fun.
ooh.
We need the biggest person in here and burn it slowly.
Who
I'm gonna tell you.
Exactly. It's between him and
Don't say
Jane.
I won't. Don't say I won't.
Get over here and leave her be.
I'm gonna need you to move her.
Should I take it?
She makes me unsafe with my feet. Everybody wants to press me. But they not.
Jane, look.
I've been over here behind my head.
You just said.
You are childish.
Always talking.
Why are you always the one struggling with this laptop? In case you haven't noticed.
Jay, why you got out of these?
My name's Dave. No, we're
It's
not.
like all of them.
Jamie, you spelled that name wrong.
Add me.
Oh.
Hey, add me.
Has Andy changed his name?
What?
Yes.
Add me. Add me.
Technically have me laughing. I can't take her serious.
All right, we need one more. Who are we missing? Tomas, or is he in there for a change? Oh, he's there.
Justice is there. You want to be right?
Let's go.
Oh,
And you need a periodic table. One you can see.
What's the largest radius?
Hush, do it yourself. This is for practice.
G. So,
Those numbers are the atomic numbers. They'll be find them in case you can't figure that out.
all right.
Hey, the atomic number. It's a group 17.
come on now.
What? Yes.
Oh my God.
I got it.
Yeah. All right. So, atomic radius. Look at where they're at. You've got GE, which is here. You've got SI above it. You've got CL here and BR here. As you go across, it does what? You get smaller. As you go down, it increases. So these two are smaller. It gets bigger as you go down. So it's GE. Okay?
Whoa.
Oh, I clicked it.
I go guess and say you in the wrong.
Because I thought that's it.
Okay.
I'm about to leave.
Mario, I'm gonna stop messing with you.
Hey,
What?
I got it right.
All right. So most reactive needs to be in what group? 1. Is there anything in group 1?
No.
So the next most reactive is what group? And you got 2 of them in group 2, so you have to look further down. That's why it's BA.
Oh, I know this one. First.
Dang, I clicked the wrong one.
All right. Largest electron negativity. Doesn't mean who picked AR. Okay? Electron negativity increases as you go this way, right? Who do you leave out? The exception is the noble gases. So that's why it's not AR. All right, who's the largest ion? First who? CS is in group 1.
It's just like
Ow! Alright,
Yes.
what can you tell me about all of those numbers?
They're in the same group.
They're in the same group. So what happens is you go down the group.
It's smaller.
They get bigger.
What? I just wrote it down.
Okay? Ionization energy, I'm sorry, ion and atomic radii are the same thing. Radius increases as you go down. Okay? Size. Largest is size. Okay? So it's the same thing.
Hold up. What?
Because I wrote
Yeah, you
ion
said.
energy.
This is ionic radius or atomic radius.
For ion, it said.
Okay?
bigger than
Ions.
the-
I would say ionization energy if I was talking about ionization energy. If I just say plain on ion, that's talking about,
So you cheated us.
I didn't cheat you.
Cheated us.
This is an ionic radius.
You knew what you.
Okay? Well, I knew what I was doing. Yeah, y'all didn't know what you were doing.
It's your fault.
Okay, it's my fault. Do you understand
Okay, so
the
I'm-
difference?
No, I'm confused. So what? Okay, so what's
Okay.
the difference between that one and the one that you talking about?
The one that I'm talking about right here is size. Okay? When I say which
Like, how do you-
ion is largest, if I want to know what you're talking about, I will say ionization energy. I'll use the whole word out,
You
ionization
just
energy.
talk about ion.
It's
It's
size.
like metal.
Yes. Okay?
Answers in the back.
You and Karen been saying that.
Because it is.
There's a hard man.
And it says 11 was the right answer. All right, so which element is the most stable? Most stable has to be a what? Noble gas, because it has 8. All right?
Check.
None of these are in the what block? Are in the D block. The D block was the next most stable area we picked. So I'm not sure why any of us picked those others. That's in group 1. That should never be. That's in group 2. That should never be. At least the blue is sort of. So I could sort of see where you'd pick that. All right. Which has the smallest atomic radius? All right. What does atomic radius do as you go across? All right, decreases, and then it increases, right?
Yep.
So when you look at where all these are at, you got BA, you got SR, you got CS, and RB. So what happens as you go down?
It increases.
That's right. So that takes those two out. What happens as you go across? They get, that takes BA out.
No, you mean it takes S.
Oh, sorry, I did biggest. Excuse me. I did biggest. Let me fix that. Should look at the question. Sorry. I didn't look at the question. All right, let's do smallest now instead of largest. This question said smallest. So if we're doing smallest, what happens as you go down?
Increases.
Yes, that takes those out. All right, so what happens as you go across? So if they get smaller, that takes RB out. So who's the smallest? SR. That's why it's green. I did the process right. I just did the question wrong. Okay. All right. Which element will gain 3 electrons?
Oh, gosh.
Oh, I know this.
Right.
Alright. So, why did 6 of us pick red? Because they will do what? Green, or the red, sorry, will lose 3 electrons. Aluminum will lose 3, not gain 3. Alright, what's the oxidation number for Se?
Mine is not loaded. Oh my God, I keep on picking the wrong one. Oh, I messed up.
Yes, with the challenges.
All right. That's good. Very good. Yes, he does. He's just playing. Alright. Highest melting point needs to be at which block? The D block, which is why it is not here. So, what comes next after the D block? The P block. So who's in the P block? Al, that's why it's aluminum. Okay? Everybody knows D, that's why I changed it up a little bit. Alright, so what we got this time? Alright, that's much better. I like the looks of that one. That's good. Good. Why didn't we pick bromine for the 2 people who did? Why is it wrong? Gets more reactive as you go. Good. Alright, what's the third period element with a half-filled P? I told you this would still be hanging around. All right, so when we look at this one, first of all, it has to be third period. Silicon is in the third period. It only has how many P's? It only has 2. It says P1, P2. P1, P2, P3. That's why it's P3. 1, 2, 3, third period. All right, manganese is in the fourth period, and it's a D block, which some of us picked, one of us picked. Arsenic is the P block that's in the 1, 2, 3, 4th period. What else do we pick? Silicon, which we were talking about. What's the first element in the lanthanide series? I better have 100% on this one. I'm going to be highly irritated if we don't have 100 on this one. Yes. That's what I'm talking about. This is another one better have 100.
Wait.
Number 14. Huh? I'm glad you are. You're just tired. 11 hours is tough for this old woman. All right, 2 of us picked 6.
Didn't even let me pick.
Oh, it didn't?
No.
All right, I'm gonna assume that the 2 people who picked 6
Now
would
it's
have
on the 4.
been right. I don't know why we picked 6. I got nothing.
6 starts with S and C.
I don't know. That's a good enough reason. I got nothing. Okay, which element has the largest ionization energy? Alright, so as you go across, it gets bigger. So argon would be the biggest. I'm guessing y'all got electronegativity confused again and stopped and didn't pick the noble gases. Okay, that makes sense. Alright, I think we're on the last question. Yep, last one. Which element is the hardest?
Helium is the trend. As soon as the boiling point.
God.
Alright, it's the same as the bowl point. Next time
You got it right. Show
you
yourself.
Alright, so 8 of us got it right, 3 of us got it wrong, and a whole bunch of us didn't answer. So we might be like Sophie, and our phones wouldn't let us put an answer in, or maybe we just didn't get it done in time. But if you're like Sophie and your phones are giving you a hard time, next time use the computer. Alright, sometimes I know that cell phones on guest Wi-Fi are difficult. So use the cell phone, or I mean the computer instead of your phone. There's no D block element here, again, by design, because most of you at this point know it's a D block element. So if there's no D block element, what do you have to pick? P block. GA is a P block element. Okay? All right. There are the results. Okay? Okay? Questions? All right. Nice job. All right. Selena's up there this time. Just ignore him.
Stephanie, we can jump in one question.
All right. If y'all will, put the laptops up if you have a laptop. If you have your phones out, put your phones out. Put your phones up. And
Pull your phones out.
I said, put your phones up and find your notes. We're going to talk about bonding. All right, apparently you're not going to let me do that with that open, so go away. Now let's try it. Yep, now you let me do it.
Oh. Man, what's going on? I don't.
Any other type of work?
Notes, new stuff.
Because they were at a
Why did you try?
What is a bar?
Because I tried it on there, but I didn't know. That's what I was gonna get. So when I went home and I was like, well, yeah, that is dressed on. Then I went to
That's what I was gonna see.
Is this title called bonds?
Bonding. Alright, has everybody got their stuff? Alright, now for homework tonight, oh shoot, I'm just telling you. You have a quiz Monday. Shh, I already told you you have a quiz Monday. And you have a lab, it's a puzzle. The puzzle counts, are y'all listening? The puzzle counts as a lab grade, just like your lab report does. Except that it's graded for right and wrong answers. You're gonna take the stuff like we just did. You're gonna take clues and fake elements. You remember that puzzle we did before the test where you had letters on the periodic table and you looked at clues and you had to figure out what letter matched the clues? Well, this is gonna take clues and you gotta take letters and figure out where they fit on a blank periodic table. Some of you are gonna like it, some of you are gonna hate it. Okay? I don't really care which category you fit into. Alright, every letter you put in the wrong spot is -3. Okay, if you miss one, you're guaranteed to miss what? 2. You're down to 94. Okay? Now, then you can just start dropping from there, 91, 88, and so forth and so on. Hopefully, a lot of you will score hundreds. Every year I have lots of hundreds. Some years, I have less hundreds. Just depends on how much you know, how much you remember. You get, one partner gets a periodic table. I strongly recommend another partner pick a different periodic table. I always recommend you pick one that has numbers like the orange one, because there are clues that are going to give you things like atomic numbers and neutrons and protons and things. And if you pick one of your colored ones, then you have no numbers on it to be able to use. Now, given that, if you choose to stand where you can see that one, that is one of them. Okay? And you get another one. Now, I would recommend your other one be based on what you know. If you are really good with using your 1, 2, 3, 4 SPDF one, I wouldn't choose that one. I would choose the one you know less well. If you don't remember the states, like if it says so-and-so is a gas, and you don't remember which elements are gases, I'd probably pick that. Okay? If you're like, dang, I can't do those configurations. Some of the clues are going to give you S2, P, D something, F something. You might want to pick that one. Okay? Whatever you and your partner think are your weakness is, choose that periodic table. Okay? But you get 2 tables, 1 each. And then the clues. You do not get the entire class period. Okay? 45 minutes max. Yes, sir.
How many gases?
11. 6 double gases and 5 others.
Okay, thank you.
Okay? And then, of course, we'll do our quiz.
How many will we have to find? Like, how many?
Actual answers,
Yeah.
I'd have to go back and count them up. It's all main group. There's 3, 4, 7. I don't know. Probably like 20. It's not a ridiculous number. Okay? It's not that challenging. Okay? Now, that's your homework tonight, is to be prepared for those 2 things on Monday. Okay? Now, we're going to talk bonding for the rest of the class period. Bonding is our next unit of study. Unless I have change of heart over the weekend and decide to break the test into 2 pieces, periodic table and bonding is still 1 test, 79 questions. So, here's one.
We get 2 class periods? Class period and a half?
1. Now, what is a bond? All right, and these are just notes that I've had because I had to do it for a sub 1 year. And since they're all typed pretty and no one's going to say, what's that say? I just sort of use them since I actually typed them. Now, what is a bond? It's a link between atoms that results from the mutual attraction of their nuclei for electrons. Give you a minute to write, and then I'll explain what that means. All right, caught up with me?
Yep.
Same period there. Because I'm done for the board today.
For electrons.
All right. So what do I mean? I mean that, let's say, this is my nucleus, and this is my nucleus, right? I've got some electrons, and I've got some electrons. Doesn't matter. This nucleus is attracted to those electrons. This nucleus is attracted to those electrons in a bond. Okay? So I'm not saying that the nucleus is attracted to its own electrons in a bond. Okay? The nucleus is attracted to the electrons in the other atom. The nucleus here is attracted to the electrons in the other atom. And that's the attraction that holds them together in a bond. Okay? Does that make sense? Okay? They're not attracted to their own electrons. They're attracted to the other electrons. Okay? So if I was going to bond with Xavier, and Xavier had some electrons, my nucleus would want his electrons, and his nucleus would want my electrons. Don't think dirty, people. I know y'all are teenagers, but work with me here. Now, there are three kinds of bonds. We've talked about two of them sort of peripherally this semester. When we talked about naming, we talked about ionic and covalent only. We didn't talk about metallic at all. Now we need to bring those into play, and we need to talk about their electrons. Now, we talked about them only a little bit and not their definitions at all when we talked about them week 2 and week 2, 3. So now we need to go back and we need to talk about not only how to identify them, which is what we did, and we need to talk about their definitions and how we would identify them a different way. If I give everybody time to catch up.
Yes.
Okay. So, an ionic bond. The top definition on the board, okay, is a definition that we're going to talk about now. If you had a good middle school experience or your biology teacher taught it, you might have seen it. A bond where electrons are lost and gained. You can also define this as a bond where electrons are transferred. Means the same thing. Okay? If I have electrons and I give them to Sophie, I lost them, she gained them. You can say that I transferred my electrons to Sophie. That's an ionic bond. Now, we didn't talk about that definition way back in January, early February. How did we identify an ionic bond way back in early February? It's on the board. For those of you who were talking last one, I don't remember. We looked at the periodic table and we said, oh, metals and non-metals. So, way back in February, when y'all all said, I had a sub in this wall, I don't remember any of that stuff. we looked at the periodic table, and you said, oh, metals are over here. Non-metals are over here. And you said, if it was a metal and it was a non-metal, it was an ionic bond. That's what we did way back in February. Now, we know now that what happens over here on this side? This side does what with their electrons? This side loses electrons. What does this side do? This side gains electrons. That's why ionic bonds lose electrons and gains electrons. The metals lose, the non-metals do what? Gain. This one transfers electrons to this one when they form a bond. That's what happens. That's why they're called ionic bonds. Are you with me on that? It's just a definition, people. Y'all should not look tired. You got out at 12:30 yesterday. I'm the one who worked 11 hours. I got more pep than y'all have.
Some of us had stuff to do.
Really? I graded 8 sets of papers yesterday and stayed here till 11 o'clock. Or 7 o'clock.
More.
Really?
Some of us
Yes,
had to go home and relax.
Ourselves. I am one of them.
I still have your lab paper to grade yet. I'll remember that, but I'm grading your paper.
That was the way.
Yes. I'll remember that when I grade Andy Casados' paper. Yes. I will.
I would put it in the door.
Yeah, to go home and relax. All right. A covalent bond is a bond where electrons are shared between the atoms. All right. The electrons are shared between the atoms. Okay. Now, how are we going to determine if they're covalent bonds? And I hope Tomas is not going to say, I'll remember again.
Non-metals and non-metals.
There you go. Okay? So, we should remember. And when we did this,
What does that mean?
they all came from being on this side. Now, because we know all non-metals gain electrons, if they're all going to gain electrons, what are they going to do when they gain? They're going to share. Okay? And I will show you how that works next week.
Oh, boron loses.
Huh? Boron's a metalloid. It could go either way. Okay? But I will show you how that works. It's going to lead us into what we call Lewis structures, and we're going to draw Lewis structures where we're going to actually draw things like this, and I will illustrate how they share their electrons. Too bad. Don't learn anyways. Sort of non-negotiable. We're going to draw things like that. Some of you will like it, some of you won't. And then we're going to learn to tell if they're geometries and if they're polar or non-polar. All right, everybody there? Got what they need?
Yes.
All right, so when you got it, Justice, that you're the one who hollered no.
Ready for prom this wall?
Are you gonna be chaperoning?
I'll be there for a while.
I'm gonna say hey, dude.
You got the early one, don't you? I knew you would.
I do.
What do you got it? What time does prom start?
I think it's 7.
Oh.
Is it 7 to 1 or 7 to 12?
7 to, I don't know.
I think it's 12.
Maybe 12.
Because they did 8 to 12 last year, I think.
I don't know.
But if you think about it, nobody's gonna show up at 7 o'clock.
Yeah, there'll be virtually nobody there. At
Like
7.
my dinner reservations aren't till like 7. Or
All right. So if you look at the definition for a metallic bond, a metallic bond is the weird one that we'll talk about later next week. Okay, we won't do metallic until I want to say about Thursday of next week. Okay, an electron is donated to a region in space. And next week on Thursday when we're talking about this, I'm going to call it the electron C model. And y'all are going to be like, what? You didn't call that before. Yes, I did. And I'm going to tell you to look back at it. Okay? Because in a metal, the electrons are not tied to any nucleus. These electrons can move wherever it is they want to go. They can move throughout the metal. Okay? They can go wherever they want to go, which is going to give the metal some unique properties that other types of bonds don't have. For example, can anybody tell me something metals do that other things don't do? Yes, they conduct electricity. We should not stick a fork, for example, in that outlet, or what will happen? It is, okay? Ionic and covalent compounds will not do that, okay? The reason for that is those electrons are able to move. Well, it's also going to shock the snot out of you. And it'll just trip the outlet. It'll turn off now because we have a safety feature on that.
That'll kill you.
Will it kill you? Probably not. All right, now, the biggest problem students have with this one is notice what it says. Stop. It can be any metal or combination of metals. Does it have to be two different metals? No. Everybody in here has aluminum foil at home. So if I just, most people do. If I just write Al, what kind of bonding is in aluminum? Metallic bonding. But if I had a roll of aluminum foil at home, do I write Al, 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 Al for all of the many aluminum atoms that are bonded together with all the other aluminum atoms? No, I just write what to illustrate the aluminum metal bonded to the other aluminum metal. No, I just write Al. Aluminum is just bonded to what? Aluminum. Okay? It's just all aluminum and it's just Al. Okay? If you have a gold ring, gold is just what? Gold. That's right. So you just write AU. That's right. Okay? Now, you might have something that's different, that's an alloy, like we might write sterling silver, which is a combination of metals, and we've given it a name because it's a whole bunch of metals, and that's what we call an alloy, but we don't have a formula for it that we would write down like we do ionic or covalent compounds, okay? So don't think because I just wrote Al that it's not a metallic bond and it's not a real bond. We just don't write a string of ALs because we have a sheet of aluminum foil, okay? It's just a whole bunch of aluminum atoms. Does that make sense? Okay. Now, this is the last thing I'm going to give you, and you might need to take a picture of it if you don't want to write it down. Okay? This is the only written homework you have. Okay?
Does it need to be on a separate sheet?
It does not. You can put it in your notes. Okay? I want you to use what we have used with the periodic table, and I want you to tell me the bond type. Oh, I need to add one. Hold on. Don't take a picture yet. Delete your picture. I forgot one.
Determine the type of using the periodic table.
Yeah. Determine the bond type using your periodic table. Forgot one. Sorry. Okay? Tell me the bond type using your periodic table. Okay? You can write it down.
Yeah, sure.
In your notes. Right now. Take a picture of it now in your notes. I don't care. But if I check homework on Monday, that's what I'm looking for. Nice and easy. Everybody should be able to have that.
Gloria, put my paper.
Yep, let me do it right now. All right, let me get rid of this.
Hold up. Hold up. I wasn't done.
Oh, you're writing it? There you go.